Hey everybody, welcome back to the HUGS project. This is episode 10, and today we are going to make a control system. Last episode we got our hands dirty, we got our dinky stinky in the old direct input cesspool of garbage, and now we are going to take advantage of that and add controller support to our game. And to do so, we're going to create a proper control system, well, semi-proper. This is me we're talking about here. Anyways, so I am prepared. I made a docket. Hope you're proud of me. On the docket, we have 3 items. First, input event extraction filter. Second, controller architecture. And third, random bullshit. So random bullshit is just some stuff that I forgot to talk about in the last episode. It was a couple of commits that I made at the end of the D input branch, but I didn't quite explain them. I forgot about it. So I'll explain those last. No big deal. They'll be done quick. The important thing is the first 2. Input event extraction. What the hell is this? So, to understand what I'm talking about here, let's take a look at the game screen and the handle input section. The way it works is it basically pulls messages out of the queue, the event queue in the keyboard object. And it checks to see if it is one of the ones we're interested in, one of the keys that we're interested in. And if it is, then it does some action, right? If it doesn't, it just throws it away. Now this is fine if we only have one thing that we're controlling. But imagine a situation where you've got 2 different things that you're controlling. So you got a situation like this where you're removing messages and checking to see if you are interested in them, and if you're not, you're throwing them away. Now take this situation. You've got 2 things you want to control. You've got your ship. Here's your ship that you want to control. But you've also got a control for pause. You want to be able to pause the game. I don't know why I made the triangle backwards. It's weird. It's kind of weird. Anyways, now, what we're going to do here is we're going to create objects, controller objects, that control things like the ship, or another controller that controls the pause function. And this is good. This is a very good system, and I'll explain why it's good later on. But it has a problem, and the problem is that this controller, if we use our normal situation of the controller basically ripping events out of the keyboard and just checking to see if any of them are the buttons that we're interested in, what you'll do is, let's say you process controller and then you process pause. Controller will empty out the keyboard of all messages, and it will throw away any pause button messages. And then when you process your pause controller, it's not going to find anything in there because the ship controller ripped all the shit out. It's a bad deal. It's not good. So what you want to do is you want your controller to look through the keyboard, but only remove the events that it's interested in. So it has to have a filter that tells it, okay, don't remove any buttons except for, left, right, and space. So remove these 3 buttons, or these 3 events, but leave the rest in the keyboard. And then pause will only remove this will only remove, enter. And so forth. You could have multiple controllers all getting events from the same object, but as long as their events don't overlap, as their buttons overlap, they won't interfere with each other. That is what I'm talking about when I'm talking about, not this, when I'm talking about input event extraction filter. So that's the first thing that I do. Let me explain it as we go. First, what you want to do is you want to go to Team Explorer, synchronize. Done. Okay. Now you want to go to branches, new branch, and origin control X. Let's take a look at what has changed here. So we'll go to changes, we'll go to history, and here we go. So like I was saying before, these two commits here at the end of the D input branch, I didn't explain them. They're no big deal, but I'll go over them quickly at the end of this lesson. First things first, I added input system. What is input system, you say? All it is a very simple class. It's really just a structure that glues together all of our different input systems. Direct input, mouse, and keyboard. And that is going to make it easier to pass that shit around to our screen classes and so forth. So that being said, there's nothing else to really talk about here. I've replaced keyboard and mouse with input system. And here I replace that with input system. And in here, same deal. I just initialize the input with window, server, case, or whatever. Doesn't matter. It's not super difficult. You can look at it yourself if you want to find out the details. Next thing is a little more to the point. Event extraction. This is what I was talking about before. So first, I only implement that for the keyboard. So what we do is we have, so in keyboard.h, we add a function, extract events, and it takes a DQ, we treat you right, and it also takes a set. And so a DQ is just a queue. It's just a list, really. It's a double-ended queue. So it's like a list with pointers going forward and backward. And a set is basically just a collection of elements. It's different than a map. It's less sophisticated than a map. A map has a key, and then it has the actual the data that you want to store in the map. So you can search for something by key and then get the data you want. With a set, the thing is the key. They're one and the same. So it's just basically a list of things, and it lets you keep track of what is in the list. It's also ordered, I think, although there is an unordered set as well, and it's faster apparently. Anyways, it doesn't matter. I changed the queue to a DQ because queue is a very limited container, and it doesn't let you iterate through all the items in the container. And as we will see, that is important. You have to be able to iterate through all the items. So because we changed from Q to DQ, we have to change from pop to pop front, because in a DQ you can pop front, you can pop back. With just a standard Q, all you got is a pop. So we change that and all the other instances. See, pop, pop front. And down here, same deal. Push is the same deal. You can just push with a Q, but with a DQ you can push back. And a stroker to the east and a stroker to the west. Stroker to the woman that I love best. Here's where we have all of the magic happening. So here's the extract events function. And it's going to make heavy use of some STD algorithms. So the first algorithm that we use is remove if. And I think it's pretty much self-explanatory. You remove all items from the container that satisfy some condition. So you pass it the, the iterator to the first thing you want to, part of the range you want to apply this algorithm to. And then the iterator to the last part of the range you want to apply the algorithm to. And then you supply it with a function pointer to the condition that you want to govern whether or not the items are removed. So you can pass it a standard algorithm predicate, they're called. These are called predicates. And you can pass it like a standard one, like less than or greater than or something. I don't know what all they are. There's a bunch of them. Equals. Or you can make your own predicate, which is what we do here. So I'm using a lambda expression here because I don't want to make a separate function somewhere just for this bullshit. So the lambda captures two variables by reference. It captures out, which is a queue of events that are going to be extracted. This is where all the extracted events go into. And it captures a filter, which is just a set of events or event identifiers that are the events that we're interested in, the ones we want to pull out and put in the queue, the ones we wish to extract. That's the filter. So it captures these, and it takes as a parameter. The parameter is the thing that will change for every element in the container. It will pass a different parameter, but these won't change. They're captured. They stay the same for every invocation of the predicate. So we pass it just the key event, which is the element in the container. Constant reference to the key event. And the function is going to return a bool. And the bool return is going to signal to remove if, whether or not we want to remove the particular element. So what we do is we just cache a, iterator to the end of filter. And then we call filter.find, and we try to see if the code for the event is in our filter set. And the way you figure that out is if it's in the set, you get an iterator to that set element. But if it's not in the set, you get an iterator to the end of the element, which is the element past the last element. So that's how we get this. So we can compare with end to see if it exists in the set. If it exists, we push out the event into the output DQ. And then we return true, telling remove if to remove it from the DQ in the keyboard. Otherwise, we return false, saying that we weren't interested in, leave it in the queue. Now, remove if can't actually delete or erase the elements. All it does is it reorganizes all the elements in the container so that the ones to be removed are at the end of the container. And it returns an iterator showing you the last element or showing you the new end of the container. This is the new end. So now that you have the new end, you have to call erase to erase all the elements from the new end to the actual end of the container, and then it will actually erase all the ones that were reorganized with remove if. It's complicated, but it makes sense if you think about it, because this algorithm is using an iterator to go through the container. If you start erasing elements from a container, you will invalidate that iterator. So it cannot invalidate the iterator. So what it does is instead it reorganizes the elements in the container and gives you a iterator that will allow you to erase them afterwards. That's how that works. Now, I'm going to take a drink of water. All right. So there was your standard template library lesson for today. Don't say chili never gave you any STDs. Now, this thing that I've implemented here will allow us to selectively remove events from our keyboard event queue. Let us continue on with our journey into bullshit. Here I change event extraction. What does that do? What did I do here? What did I change? Okay. I added a new class called keyboard filter. So if you'll remember before, I passed in a queue to receive the extracted events and a set to indicate which events we were interested in. But now I just pass in a keyboard filter, and that contains, it basically encapsulates and contains these two things into one convenient lump called a filter, a keyboard filter. And it does the same stuff. It holds the same kind of shit, and it supplies the user of the filter with some functions to allow you to remove events that were extracted with the filter from the filter, and to check to see whether the filter is empty. the filter has a friend in the keyboard client, and that allows the extract events function to use the private members inside there. It allows it to touch its private parts, which is always important, to let your friends touch your private parts, because that's part of friendship, right? That's at least how my uncle told me about it. Anyways, so that's how you do that. Nothing has really changed here. I don't think I fixed any bugs. If I did, I don't remember. Doesn't matter. That is how that works. That's how the filter works. Control system keyboard. What is this? All right, so here's where we actually implement a controller object. So what is a controller object? Well, it is point 2 on my masterfully prepared docket here. Controller architecture. Let me introduce you to my grand architecture. So the idea is, I don't know why I got this stop sign thing here. There we go. The idea is, that you got to pronounce it like idea. I don't know why I'm talking like this. Is that you're going to have a, what do you call it? A virtual class called, stop it. I'm getting pissed off. Called ship controller. And it is going to maintain a reference or a pointer or something to a ship. And its job is, when we call a function like update on ship controller, it controls the ship. And controllers will be owned by screen, like game screen or title screen or whatever. Now it's a virtual function or a virtual class or whatever you call those things. I forget. Abstract. Fuck, I got the word. Abstract. It's an abstract class. So it's going to need a concrete implementation. And one concrete implementation will be the keyboard ship controller. So it's going to be a ship controller. It's going to have a reference to the ship, but it's also going to have a reference to the keyboard. So when you call the update function, it's going to get input from the keyboard, process that input, and call functions on ship to control your ship. Very simple. But there's more. Because we can also have other kinds of controllers that inherit from ship controller, like the pad ship controller, and it will have a reference to a gamepad, and it will process that input to control the ship. And you could also have, let's say, a net ship controller, and it will control the ship based on input from a socket, like a UDP socket. So the beauty of this system is that the game screen doesn't give a shit what kind of controller you have. All it knows is it has a pointer to a ship controller, and if it calls the update on that, the ship will be controlled, and it doesn't care whether it's going to be controlled ultimately by an internet connection or by a gamepad or by a keyboard. It's all the same to game screen, and that's what we like in programming. So that is how it works. Let us see how it is implemented. So we're going to go to ship controller. And as you can see, it's a very simple abstract class. It's got one pure virtual function called process. And it has a reference to a ship. Now, if we look at ship controller keyboard, it adds to its repertoire a keyboard filter and a reference to a keyboard client. And it overrides the process function. And what it does is it does keyboard.extract events filter. So it calls extract events on keyboard, passing it our filter. And then it processes the contents of filter by using, the filter empty. While not empty, do this bullshit. And it does a bunch of bullshit here. And the bullshit is the same as the bullshit we were doing before. Get the code. If it's left, spin left, or stop spinning if we release the left button. If it's right, if it's space thrust, otherwise stop thrusting, whatever. Doesn't matter. We know this. This is known Khaleesi. When we create the filter, we create it with this initializer list. Very convenient, easy to read. I didn't actually talk about that. the constructor takes an STD, initializer list of unsigned ints, and those are the keys. So you can use this to allow you to pass a randomly sized list to, not randomly sized, but arbitrary sized list to your constructor, which is useful. That's a new thing in C++11. I say new, but it's like 2015 now, which is kind of weird. It's new for me because I'm an old bastard. Anyways, so that's how it works. You initialize your filter, you initialize your reference to your keyboard and your ship. This is the base class ship controller, so you got to call the base class's constructor in the constructor here. We know this. We are programmers of the C and the ++. In game screen, what we're going to do is we're going to add keyboard controller. We're adding a new object in here. And yeah, we added it down here. See? I didn't lie. What did I add up here? I added ship controller keyboard. And here, I added that while not, which I should have had there at the beginning, because you should process all messages until it's empty. So I added that for the case when it's dead. If the ship is dead, then we forget about controllers and we just directly empty the keyboard input queue and process it to check to see if we've pressed return. And if we have pressed return, then we start a new game. But anyways, that's not important. What is important is we've gotten rid of all of this bullshit in here, with the controlling of the keyboard. And now the keyboard controlling is not the purview of the game screen. It is now handled by keyboard controller. We call its process, and it does all the work for us. And there you have it. Bob is your uncle. What's next? Input system incorporated. Okay, all I did here was now I pass input system to our constructor. Instead of passing keyboard in, I pass input system. And the reason is because then I can have access to keyboard, gamepad, and mouse, all in one convenient package. So I've implemented that in the title screen and in the game screen. But I'm still just passing input.keyboard to my keyboard controller. That part hasn't changed. There we go. It's keeping track of input system instead of keeping track of the keyboard client. And in game.cpp, now the constructor here takes input instead of input.keyboard. Nothing very groundbreaking in that. Here, we add support for the gamepad in the ship. So what is that? All right, so we create a new ship controller gamepad, and it works much like you would expect. You call get stick position. What is this? All right, there's a bunch of bullshit in here. First of all, in D input, we fix an error in here. What is this? What is this function here? Update. So the update function had a switch statement in here to check to see. This was for the POV hat. Did I fix that? Yeah, I did. I fixed RGB buttons. I changed it to POV, which is that thing I talked about in the last episode. I also added breaks in here because it wasn't breaking. So if we hit case 0, it would set position to this, but then it would also set it to this, and this, which is bad. So in any case, the position would always be set to 0 because it would always end up to default no matter what. Not a good day. So I fixed that bullshit. And what else did I do? I think that's it. So ship controller gamepad is not using, at the moment, it is not using a filter for the gamepad. So it's going in there raw dog. You're going to get your STDs or not. The filter has more STDs. So actually, it's, what am I talking about? Anyways, we're not using a filter yet, but we are using the gamepad. and it is directly removing events from the pad. And again, if the event, let me see. So if we check the type of the event, if it's the stick, and if it's the first stick, which is index 0, then we check the position of the stick, and we spin the ship based on the position. Otherwise, we stop the ship from spinning. And here, if a button is pressed that we're interested in, button 1, then we thrust. Otherwise, we stop thrusting. And that is all. Very simple. Much the same as for the keyboard, only with the gamepad. And if we do this, we have to add the pad controller in here. So here we have a situation where we're actually controlling the ship with two different controllers. So it allows simultaneous control from the keyboard and from the gamepad, which doesn't cause you a problem. Only you see here that it's actually if the two conflict, if the gamepad sends a command at the exact same time as the keyboard is going to win because it's processed last. But other than that, it works fine. Having two controllers control the same thing does not cause any problems. And in game... Oh, this is important. This is the thing that I forgot at the end of the last tutorial and caused me problems. You've got to, in your update now, you've got to call the update function for your gamepad. Otherwise, it will not update all of the event queue and the gamepad state, which is not good, obviously. So that is the gamepad implemented in the system. Now we add filter to the gamepad. So how this is done is this pretty much the same as in the keyboard case. So we add things like set, because it's important to be able to understand what a set is if you're going to make a filter. And I just added some bullshit here. I set these ones to specific values, and I put some comments in here to make it easier when you're typing. Because these comments, they show up in IntelliSense when you're typing out. Okay, here is important. The filter needs a single value in order to basically check to see whether the event is an event that we're interested in. So in order to generate a single value from a button event, we have to hash together some different values. We've got to hash together the type of the event and the index, right? Because if we just use single values by themselves, then two different buttons will have the same filter value, and that's bad, right? If we just use index by itself, an event for the stick 0 will have the same filter value as an event for button 0, even though they're completely different controls. So what we want to do is we want to hash together the type of the event and the type of the control for the event and the index of the control together to create a unique identifier for the control. And the unique identifier for the control will be the unique identifier for the event. So that is why I set these to specific values, because I wanted to make sure that they were, the type will be a 2-bit value, right? 0, 1, 2, 3, that's 2 bits. So then you bitwise or type with index shifted left by 2, and that will give you an unsigned int for your hash value. I got rid of const in here because it's bad, and maybe it was causing problems. Generally, you shouldn't make your member variables of a class constant. It's not a good time, and I have the bad habit of doing that. But I'm weaning myself away from it slowly. And then I added the filter class, which is an internal class to gamepad. And that's different than I did for keyboard, but doesn't matter. So in the filter class here, we've got the same bullshits here. We've got empty, which checks to see whether the filter is empty, and get event, which gets an event. I've also added another function here called add condition. And what that does is it allows you to insert a value into the filter. So it's just filter.insert, and then you pass in an event, and it takes the hash of that event and inserts it into the set of filter values. So this allows you, before with the keyboard, you only could set it up in the constructor and that was it. But this one you can add filter things on the fly. Filter conditions, I guess. Here we have, so I changed, again, same as for keyboard, I changed the Q to a DQ. So I have to change in place to in place back. In place and push are basically the same function, but in place causes less overhead. If you're constructing, it allows you to construct using these parameters, whereas push back takes an existing object and copies it into the container. Slightly different, but in place back can give you a little bit of performance enhancement sometimes. Not a big deal. All right, so here we change in place to in place back, pop to pop back. I still didn't fix this, which this should be a while, but I didn't fix it. Maybe I've forgotten. Maybe I should probably fix that someday. Remind me if I haven't, like 3 months from now. And again, we have the extract events function, which does the same bullshit as I said before. Remove if, use your filter, get your STDs, and then erase bullshit at the end. Doesn't need explaining. I added pause controller and pause controller gamepad because I was going to implement the situation I was explaining before, where you have two controllers that get events from the same source of input. But I actually did not implement this. I was like, I'll do it later, because it was a pain in the ass to try to implement pausing. Not that it's that difficult, I just didn't feel like it. So, what are we going to do here? Oh, I also did one for the keyboard. And what do we got here? What is this? Ship controller gamepad. All right, so here... All right, so yeah, we changed this to use the filter system. So we go gamepad filter, we add that. Why do I have thrust index? Oh, I think this is the index of the button that we use for the thrust button. I just added that as a constant in a class, which is a bad idea. Still can't kick that bad habit, can I? Anyways, so in here, we initialize the filter by calling add condition twice. And we add D-pad event as one event that we're interested in. And we add the button event as another event we're adding. So the way you can, these events, the way you can tell whether it is a stick event or a button event or an axis event is basically the signature of the constructor is different. And I don't particularly like this situation, actually. It's not very explicit. You can't just tell by one look that, oh, this event is a button event. You just have to know that if the event takes an int, unsigned int, and a bool, it is going to be a button. And if it takes an int, unsigned int, or no, I don't even know what this is. And if it takes an int and a vector, then it's going to be a stick, a vec2. But anyways, that's how that works. So again, now instead of just emptying out the pad, we extract the events with the filter, and then we empty out the filter. Otherwise, same bullshit. And that gives us our filter stuff. Now, the very last thing that I've done in this branch is I changed the way we control the ship, because the ship's controls, if you haven't noticed, are kind of janky. It's freaking hard to control. It's unwieldy. It's like freaking, I don't know, Kerbal Space Program, only without all the cool parts. So, what I've done is I've changed the ship control from us controlling the rotation of the ship to us directly controlling the direction that the ship is facing. So the ship will immediately spin to the direction that we indicate on the D-pad. And that is much easier to control. So the way I've done this is I've changed the ship's control scheme here. So I've changed all of this angular velocity and such bullshit in here. And that is all gone. Now we've only got the thrust part. We just have a direction, dir normal, that's the direction that our ship is facing. Multiply that by thrust and apply the force, and that's it. There are no more functions to spin or to stop spinning. Or there is a function to spin, but all it does is it sets the ship's direction to face the direction that we pass in. So it's an immediate change of direction. And in order to do that, we get rid of all of this bullshit and we replace it with a single vec2, indicating the position that we're facing. And that's it. Now, the tricky part here was figuring out the direction or the translation matrix bullshit, the rotation angle from the vector, because we're given a vector. We need an angle in order to derive the rotation matrix. So that formula is in here. There's a function in math that's very helpful called atan2, and that allows you to pass x and a y, and it gives you an angle of that x and y. And we have to add pi over 2 to that to make it line up with our system. But that's it. Very useful function. And in ship controller has become a lot simpler. Now, instead of doing spin and stop spinning, all we do is whenever we get an input on our analog stick, we do what? Let me think here. We check to see if the input is 0 and 0, because if the input is 0 and 0, that's not a vector at all, and that will cause a problem if we try to set our ship's direction to that, because that doesn't indicate any direction at all, right? So if it is 0, we just don't do anything. We leave the ship in the direction that it's facing. That just indicates that we released the analog stick. But if it's not 0, then we normalize that direction and we set the ship's direction equal to that. And for the keyboard, we do the same thing, but only for keys. So if we press down, we set the direction to this. And if we press left, we set the direction to that. We actually add them all together. And then we normalize the result and set the ship to that. So that means if we're using the keyboard, we only have 8 directions of freedom. 8? Yeah, 8 directions. It's kind of harder to control, but it works really nice with the keypad, the gamepad, which is what I will show you right now. Build a solution. And run it, and we're in release mode. I hope my gamepad is all set up properly. I'm not exactly sure. Oh, got some bullshit in there. Okay, we'll put this as much as possible on the screen. Press enter, because the menu is still only hooked up to the keyboard controller. Or I think it's not using controller system at all. So here is our ship, and you see here I can control its direction with the gamepad, the analog stick here. It looks kind of janky if you just press random directions, but normally when you're using it, it looks like this, which actually looks pretty cool. So I think A button is our motion, and now, if you remember before, I could barely get past the first corner. But with this control scheme, there we go, I've said it properly. It's actually not that difficult. I can make several laps with ease. And I'm not going to say it's fun, it's still pretty rudimentary as a game. But this, I've warmed up to this kind of control scheme over the other one. Even though it's not technically it's not physically accurate, right? Generally, ships can't just rotate instantaneously to any direction that they want. Or ships any object, right? you've got a thing called angular momentum, moment of inertia, if you will. And that is the thing that makes life difficult. For rotation, but if you don't have that thing, it makes it really easy to control the ship. And so we're going to stick with this for a while. After I've fleshed out some of the other parts of the system, the audio and the graphics and so forth, and then we'll take another look at our control scheme and the final control scheme that we want for the game. But for now, I think this is pretty good. And it's a hell of a lot better than what we had before. What else? Okay, so last thing on the docket is the random bullshit that I was talking about before. Let us talk quickly about the random bullshit. The random bullshit that I am mentioning here are these two commits that I made. First is anti-aliasing text. So, I didn't think you could do anti-alias text with this situation here where we're rendering to a bitmap that was created on an existing memory buffer. But apparently all you need to do is you have to change the format to non-alpha format, and that will allow you to do it. Now, to set the text rendering to use anti-aliasing, you've got to set text rendering hint anti-alias, and it will make your text pretty. There are other settings, I haven't tried them. Anti-aliasing looks like it's perfect for me. That's all you got to do, and now the text looks prettier. So, to just show you what are all janky, and like the number here, jaggy edges, and if we commit seppuku, here we will see, yeah, it looks ugly. It looks like garbage. But the other one that I showed you looked sexy because it is sexy. So that is a good thing that we did. Let's look at another good thing, sort of good thing that I did. All right, fixed message pump. What is this? So in a different thing that I was working on, I found out that for some reason, when you close the program, this line, the program never actually reaches this line. You never call unregister class. So I changed the message pump so that this will be called when you close your program. I don't know why it's not called, but I'm pretty sure it isn't. Let's try quickly here. We'll go to branches. We will go to menu again. We'll go here to game. Not game. We want to go to Windows. It's in the framework. Windows. And scroll down to the bottom. Set a breakpoint here. We'll go to debug. And if I close the program, this shouldn't trigger the breakpoint. Well, it should, but it doesn't. That's what I'm trying to say. Close, no breakpoint. Just engine has exited with code 3, which is an error. See, thread is exited with code 3. So for some reason, this is causing bullshit to happen when we exit the program. But if I change, where's the input? There we go. If I change that message pump to this one, where we return 0 here, we just have a infinite loop here, and if message equals quit, we unregister and return 0. This should not give us an error. Don't make me a liar. See? No error. Wait, so we get our breakpoint here. So we actually do unregister and we hit our breakpoint. If I continue, exit with code 0, no error. Well, this one exited with code 1, but we are going to ignore that. That you didn't see that. Anyways, it seems to be better than the other one, so we're using this one. Not a big deal, but it is a deal indeed. And now I have completed my explanation for this episode. So, that's everything. That's controllers, and it's better than what we had before, especially the actual control scheme is better. And next episode is what? I think it is sound, but I can't remember. It's sound. So next episode, we are going to implement sound, and we're going to do it not via direct sound, which is deprecated, but via X Audio 2, which is not deprecated, and which is probably better than direct sound, although it caused me a lot of problems. But most of those problems were me being stupid. Anyways, look forward to that in the next episode. For now, I am going to gargle my throat with battery acid, because it burns like a mother. Wait, never mind. Doesn't make any sense. Goodbye. Oh, I almost deleted the video there. Let's not do that.